a 2 power n cell key map will be formed. Okay, so for a n variable, a 2 power n cell variable key map will be formed, and each cell on the map represents either a minterm or it will represent either a max term. Okay, I will write down here. So each cell will represent a minterm or a max term, depending upon whether we are using SOP or POS. It will either represent your minterm or it will either represent your max term. Okay, so in the case of SOP expressions, we assign minterms to each cell of the K-map, whereas in the case of POS expressions, we assign max terms to each cell. Okay, so let us see the structure of K-map. So in the case of two variable K-map, so in the case of two variable, so 4 cell K map will be formed, that is 2 power 2, that is 4 cells will be present in the K map. Okay, so how it is going to look like? So let us see for the SOP form of representation, where we will have minterms, where we are going to plot the minterms. So it is going to look like this. So only we will have 4 cells. Okay, and we can represent, let's say we have a function of f of a comma b. For this, the K-map is going to look like this. You can write a here and b here, or vice versa. Okay, and here you can write 0 1 0 1, or else you can write b bar and b and a bar and a. Okay, any wish, anyway you can, any representation we can use here. And this is 0 1 2 3. This is a bar b bar, this is a bar b, and this is a b bar, and this is ab. So this is in the this is the K map for your SOP, where that is your minterms. And let us see the K map for POS form of representation, two variable K map. For two variable K map, we will have same 4 number of cells, and let us take POS. We'll take the max terms. So in the case of max terms, our K map will look same only. So 4 cells we will have, and this may be a b. Okay, this is 0 1, or you can write b and b bar, a and a bar. This is 0 1. This is case of max terms, right? So we are writing a and a bar, b and b bar. So this is 0 1 2 3. This is a plus b, this is a plus b bar, and this is a bar plus b, and this is a bar plus b bar. So this is how we are going to plot our two variable K map. Okay, coming to three variable, we will have total 8 number of cells. Just for SOP I am going to draw. So in the case of three variable K map, so we will have total 2 power 3, that is 8 number of cells we are going to have. So this is our 3 variable K map: 0 1 3 2 4 5 7 6. Let's say this is a function of a, b and c. Okay, so here we can use a, b, c. So I'm comfortable with this type of representation: b bar, c bar, b bar, c, b, c, and b, c bar. Or else you can use the second type of representation: 0 0 0 1 1 1 1 0. Okay, and you can use a bar and a, 0 and 1. Okay, so any way of representation you can follow. And if you carefully observe, we are writing 0 1 3 2 4 5 7 6. So what type of coding we are using? Can you guess what type of coding here we are using? So what is the code, whether we are using the binary code here? Okay, so basically for numbering the cells, we are using gray code. We are using gray code. So why we are using gray code? Any idea? For numbering the cells of the K map. So as we have studied, while we are studying about gray code, we have seen that each bit, each adjacent bit will differ by only one bit. Like let's say suppose 0 0 0 1 1 1 and 1 0. So there is only one bit change between the two numbers. Okay, so that's why we are using gray code representation, because in the K map we need adjacent cells to be grouped. So that's why if we use this gray code, then there is only one bit difference. Okay, so that's why we are using this gray code for numbering the cells of the K map. Okay, and this is SOP form of representation. And in the case of, let's see your POS also, it will be clear. So in the case of POS representation, this will be your K map for three variable. Let's say f of a comma b comma c. Okay, so this will be a b c. Order is not mandatory. B bar c bar, sorry. So in the case of POS, let's say we have a three variable function f of a comma b comma c, and this is a, b, c. Okay. So this can be 0 0 0 1 1 1 1 0 and 0 1. Or else you can use this representation also: b plus c, b plus c bar, b bar plus c bar, b bar plus c, and a bar. Okay, anything is fine. So this cell is 0, 1, 3, 2, 4, 5, 7, 6. So this will become A plus B plus C, so on. This will become A bar plus B bar plus C. All the minterms we will have. Okay. So this is POS form of representation. Okay. Yes. And coming to last one, that is nothing but your four variable k-map. So for four variable k-map, you will have total 2 power 4, that is 16 number of cells. Okay, so let us see first SOP form of representation. So in the case of SOP form of representation, we will have total 16 number of cells like this. And let's say it is a function of if of a, b, c, d, then we will write AB here and CD here. So you can write 0 0 0 1 1 1 1 0 0 0 0 1 1 1 and 1 0. So this will be A bar B bar, A bar B, AB, and A B bar, and this is C bar D bar, C bar D, CD, and CD bar. And coming to the labeling, the numbering, this is 0 1 3 2 4 5 7 6, and here we are not going to write 8. Here we are going to write 8 9 11 10 12 13 15 14. Since for the adjacency we are writing the numbers like this. Okay, so this is how we are going to use this four variable schema. This is for SOP form of representation. Now in the case of POS form of representation, for a four variable function f of a, b, c, d, we will have same 2 power 4 16 number of cells we are going to have, and we are going to use our max terms since it is a POS form of representation. Since it is a POS form of representation, we are going to use our max terms: a, b, c, d, 0 0 0 1 1 1 and 1 0, 0 0 0 1 1 1 and 1 0. Okay, so you can write c plus d, c plus d bar, c bar plus d bar, c bar plus d. Okay, and this is a plus b, a plus b bar, a bar plus b bar, and this is a bar plus b. Okay, the numbering and the labeling will all be same. So this is your four variable schema. Okay, so I think up to here it is clear, right? Yes. Now let us try to understand about your cell adjacency. So let us see how to plot, uh, how to group, and how to pair the things. So pairing in K-map. So we have two cell adjacency. Let us see what is this two cell adjacency. Let's say suppose if we have a two variable K-map like this with four number of cells A, B, and let's say we have two minterms here. Okay, this is A bar and this is A, this is B bar and this is B. So we can group this two cells. Okay, like let's say suppose if we have one more minterm here, we cannot group these two cells. No, this is wrong. Okay, so cross grouping, it is not done in the KML. Only the adjacent cells will be grouped. Okay, so this is nothing but two cell adjacency. And how to write the equation for this? Let's say suppose how to write the equation for this group. So whatever the terms which are common in this group, we are going to write that particular minterm. So what is the common term? A is not common, B is common, so the final answer will be simple B bar. Okay, so this is how we are going to pair two cells. Okay, next coming to quad grouping. So how quad grouping is going to look like? Let's say we have a three variable function f of a, b, c, f of a, b, c like this with eight number of cells: a, b, c, b bar, c bar, b bar, c, b c, and b c bar. and A bar and A. Like let's say suppose if we have four minterms present here. Now, how to group this? So we can group the adjacent cells. So these two cells are adjacent to each other. The two corner cells will be adjacent to each other. So this is nothing but our quad grouping. This is 0, 1, 3, 2, 4, 5, 7, 6. Okay. So this is also be possible. Now, what is the equation if we write down for this group? So we need to take out the common group. So here A is not common, and the common thing is C bar. So final answer will be C bar. So this is how we are going to make the grouping, and we are going to write down the expression. Now let's take one more example. Let's say three variable function. We have the minterms like this. Now what is the answer for this? A, B, C. B bar, C bar, B bar, C, B, C and B, C bar, A bar and A. So if we group this four, then our final answer will be simply B bar. Okay. So this is how we are going to form a quad, and we are going to write down our equation. Next type of grouping which we have in K-maps, and this is also same for POS form of representation also. Okay. So let us see for octet. So next type of grouping is octet. So in the case of octet, we are going to group uh, a group of 8. We are going to make a group of 8 minterms. Okay. So let's say if we have a K-map like this, AB, CD, C bar, D bar, C bar, D, CD and CD bar, and A bar, B bar, A bar, B, AB and AB bar. Okay. So let's say we have minterms like this, then we can make a group which is containing of 8 minterms. And what is the equation for this? What is the common term here? That is nothing but D. So our final answer will be D. So this is how we can make a group. This is how we can make a group of octet. So let us try to understand implicants in K-map. So basically in K-map we have different type of implicants. First is prime implicant, and second one is essential prime implicant, and third one is redundant prime implicant, and followed by selective prime implicant. So let us try to understand what are these prime implicants. Prime implicant, essential prime implicant, redundant prime implicant, and selective prime implicants. Okay. So implicants are nothing but the groupings. Okay. So let us see what are this prime implicant, essential prime implicant, redundant prime implicant, and selective prime implicant. First, let us try to understand what do you mean by your prime implicant. The first type, that is prime implicant. What is prime implicant? How to find the prime implicant? Let us try to understand. So prime implicants are nothing but the number of possible groups which can be made in a K-map is known as a prime implicant. Okay, I will write down here number of possible groups which can be made in K-map is known as your prime implicant. For example, if we have a three variable K-map f of a comma b comma c as like this. So let's say if we have a three variable K-map like this, a, b, c, b bar, c bar, b bar, c, b, c, b, c bar, and this is a bar and a. So let's say we have minterms. I'm taking SOP form of representation. Let's say we have minterms like this 1, 1, 1, and let's say 1 and 1. Now, can anyone tell me how many prime implicants can be possible here? So this is one prime implicant which is possible. Okay, and this is one more followed by this one. And if you observe the adjacent ones also, this grouping is also present. Okay, so these are my prime implicants. Okay, so how many prime implicants are there here? So this is first one, and this is second, and this is third, and this is fourth. So total, the prime implicants is are nothing but four prime implicants are possible. Okay, so pi is equal to 4. Is this clear? Yes or no in the chat box? How to find out the prime implicants is it clear? Prime implicants are nothing but the number of possible groups which can be made in the K-map. Example, I'm only taking three variable K-map. Okay. Now, let us try to understand your essential prime implicant. The second category, essential prime implicant. So we have a function of three variable f of a comma b comma c. Okay. So let's say we have our K-map like this with this min terms. Let's say our min terms are 1, 1, 1, 1. Okay. And this is A, B, C, B bar, C bar, B bar, C, B, C, and B, C bar, A bar, and A. So coming to essential prime implicants, these are the implicants. I will write down here first the definition. These are implicants where each minterm of a group is not shared by any other group, where at least one minterm, okay, where at least one minterm of a group is not shared by any other group. So what is this? Okay, let us try to understand. So this is one prime implicant which is possible, and this is one more prime implicant. Okay, so these are and this is one more prime implicant. So total three prime implicants are possible in this case. Okay, so here prime implicants are nothing but three. Now, how many essential prime implicants are there here? How many essential prime implicants are there here? So according to the definition, so here we can see the minterms of a group which is not shared by any other group. So this is one group which this is one prime implicant. So in this group we have two minterms. This is one minterm and this is second minterm. Now this minterm is not shared by any other group. Okay, so in this group there is at least one minterm which is not shared by any other group. Okay, so that's why this is nothing but your EPI. Okay, now in this group we can see that there are two minterms and this minterm is not shared by any other group. So there is at least one minterm which is not shared by any other group. So that's why this is also said to be an EPI. Okay, and coming to this third group, we have two minterms where this minterm is shared by one group and this minterm is also shared by another group. So you cannot say this group as an EPI. Okay, so that's why here the count of EPI is nothing but 2. Is it clear up to here? Exactly, 2. Correct. Okay, so this is how we are going to decide how many essential prime implicants are there in our K-map. How many essential prime implicants are possible. Okay, so why we are calculating this essential prime implicants? Why this is very important? Because essential prime implicants will appear in our final solution. Essential prime implicants will appear in our final solution. This is the most reduced solution. Okay, so essential prime implicants will only be appear in our final solution. Okay, for example, if we try to write down the equation for this K map, so what will be the equation for this K map? That is a bar b bar. So equation for our K map will be nothing but a bar b bar plus a bar b bar plus a c. So this equation I am getting by only considering essential prime implicants. I am getting this equation by only considering essential prime implicants. Now, if I consider the other group which is not an essential prime implicant, then what will be my equation becomes? Then my equation will become a bar b bar plus b bar c plus ac. This equation I am getting by considering a non-EPI group. By considering a non-EPI group. Now, we can easily see that in these two equations, in the third equation we have more number of terms compared to the first equation. So, which one do you prefer? The equation with more number of terms or the equation with less number of terms? Which one we are going to prefer? The equation exactly. And what is the reason why we are only selecting the equation with less number of terms? Why not we can select the equation with more number of terms? What is the reason behind that? Like why we should only select the equation which is consisting of less number of terms. Why not the equation which is consisting of more number of terms? What may be the reason for this? Exactly. So we require less number of gates for implementing this equation which is consisting of less number of terms compared to the equation which is consisting of more number of terms, and here the area is going to decrease and power is going to be also decrease. But it is not compulsory every time. Okay, in the case of static timing analysis, when we are going to study, we may need the extra redundant term also that we are going to study when we are going to see about STA. Okay. Exactly. Now, in our digital design perspective, we need only the less number of minterms. Okay, we are going to solve it. Okay. Yes. So this was about your EPA. Now coming to next one more terminology which is known as RPA. That is redundant prime implicant. So redundant prime implicant, this is a group where each of the minterm is shared by other groups also. Is shared by other groups also. So this is nothing but our RPA. Okay. For example, if we consider the same three variable K map like this, A, B, C, 1, 1, 1, 1. Okay. And if we find out the prime implicants, this is one prime implicant, this is one more prime implicant, and this is one more prime implicant. Okay. So total prime implicants are 3, and essential prime implicants we have seen previously is 2. And coming to RPA, according to the definition what we have seen, each of the minterm in the group is shared by other groups. Okay, so here this group, this is, let's say this is first group, this is second group, okay, this is third group. Okay, in the third group we can see the first minterm is shared by some other group and the second minterm is shared by some other group. Okay, so that's why this group is known as RPA. This group is known as RPA. So RPA, how many have we have? RPA is equal to 1. So this is how we are going to find out which is EPA, which is RPA, which is PA. Okay. And this RPAs will not appear in the final solution and should not appear in the final solution. Okay, I will write down here. So RPAs should not be appeared in the final solution. So RPA, EPA, PA. These three terminologies, are they clear? Yes. Now let us talk about SPA. Let us talk about SPA. Okay. So let us see one example. So basically, these are not EPAs, and we cannot say these are RPAs also. Okay, basically SPAs are, we cannot say these are EPAs, and we cannot say these are this as RPAs also. Okay, now let us try to group this. Can you tell me the answer by grouping this, and can you tell me the equation which you are getting for this? Yes, after grouping, what is the answer we are getting here? So I can group this two, and I can group this two. And what type of grouping you have done? Whether you have grouped this two or this two. Whether you have grouped this two vertically or horizontally. So here it's up to the designer whether to group vertically or whether to group horizontally. So some people may group this vertically. Okay, so some people may group this vertically, or some of them may group this horizontally. Okay, so we can group this vertically or we can group this horizontally. Okay, so if I am grouping this vertically, so if I'm grouping this vertically, then what is the answer I'm getting for this K map? What is the equation I'm getting for this K map? Is A B bar, A B bar plus, sorry, A bar B bar, A bar B bar plus A B, A bar B bar plus AB plus BC. This is the thing which I am getting when I am grouping vertically. No, we cannot group this one now. either you can group this like this or you can group like this now. Okay, either you can group vertically. So if you neglect this group, then this min term will be left alone now. Then what is your final answer if you are leaving this group A bar BC? Then number of min terms will be more. Grouping should be done for sure. You cannot leave any min term to be left without grouping. Okay, is it clear? So this min term we can group either with the below term or we can group it horizontally. Okay, we can group it vertically or we can group it horizontally. Is it clear? So if I'm making a vertical group, I'm getting this equation, and if I follow horizontal group, let me change the color. So if I perform horizontal grouping, then I will get the answer like this. If I perform horizontal grouping, then what I'm going to get? I'm going to get A bar B bar plus AB plus uh, this is A bar C. Is it clear? Is this clear or not? Yes or no? Please let me know. So for this K map, we will get two solutions. Okay. So let's say this is group one, this is group two, and this is group three, and this is group four. So this answer is nothing but this is formed by considering group three by considering group 3, and this answer we are getting by considering group 4, by considering group 4. You're not supposed to group 2. So what was your question? We can just leave this without any grouping, right? So here you cannot leave this min term without any grouping. Okay, so definitely you should group it. So here 1 1 1 1 1. So what you're saying, we can group this two and this two and we can leave this alone. No, we cannot do that. Okay, so we should always group this. Okay, so if we group it as a single implicant, then what will be our final answer? It will be AB plus A bar B bar plus A bar BC. The number of minterms will be more. So that's why what you're doing, you can either group with the below one or you can either group with the horizontal one. You can either group it with the vertical one or you can either build it with the horizontal one. Okay, you cannot prefer both the groupings. Okay, in this particular K map there will be two answers which are possible. Either if you consider group 3 you will get this answer, or if you consider group 4 you will get this answer. Is it clear? So any other for this K map there are two possible answers which are possible, either this or this. Okay, yes. So this answer we are getting by considering group 3, and this answer we are getting by considering group 4. Okay, so this is nothing but our selective prime implicant. This is nothing but our selective prime implicant. Is this clear? How we are deciding? Is it clear? How to find out how many selective prime implicants are there? Okay, let us try to understand that. 1 1 1 1 1. Okay, so let us try to understand how many prime implicants are there. So this is essential prime implicant, this is essential prime implicant. Okay, now for this min term we have two possible groupings. Either you can group it with the below one or you can group it horizontally. Okay, so I am grouping it with the below one. Now can you say this as an essential prime implicant? This is EPI and this is also EPA. Okay, now can we term this as an essential prime implicant, this particular group? Can we term this group as an essential prime implicant? No, because this was selective. This is selection, right? So you can also group, you can also make this group. Okay, so this is SPA. Okay, now there is one more prime implicant possible, that is this one. There is one more prime implicant which is possible, that is this particular group in the dotted lines. Now whether this group is RPI or whether this is SPA. Whether is this an SPA or whether this is an RPA. And in RPA definition, this is a group where each of the minterms is shared by other essential prime implicants. Other essential prime implicants. Yes. Now tell me. So whether this is RPA or whether this is SPA. In the RPA definition, I've missed this term. In the RPA definition, this is a group where each of the minterm should be shared by other EPA groups. Okay, then it will be said to be an RPA. Now tell me whether this daughter group it is an RPA or it is an SPA. Yeah, it is not an RPA. So coming to RPA definition, RPA is nothing but each minterm in group, each minterm in the group is shared by other EPA groups. Okay. So in the previous example, if we observe when we were discussing about RPA, so this was an EPA, the red line which we are seeing, and the below one is an EPA. And this, why we are saying this group as an RPA? Because if we see this minterm, this is shared by one EPA, and if we see this minterm, this is shared by another EPA. So that's why it is becoming RPA. Now, coming to this example, we are, let's say we are saying this RPA. Let us assume this is an RPA. But if you see this minterm is shared by, is this an SPA or is it an EPA? This is an SPA. This minterm is part of a SPA group, and this minterm it is a part of EPA group. So one of the minterm is not a part of EPA group. So we cannot say this it is an RPA. So this dotted line is also an SPA. Is this clear? Or shall I explain it one more time? Is it clear? Okay. So we should be careful here. So in this group, we have two minterms. One minterm is shared by EPA. Okay. But what about other minterm? It is not shared by EPA. If it is shared by EPA, then we can say it is an RPA. But this minterm is not shared by an EPA. This is shared by an SPA. So that's why we cannot say this dotted line as an EPA, or we cannot say the dotted line as an RPA. So according to the definition, it is said to be an SPA. So this is how we are going to decide. So in this particular example, our EPIs will be equal to 2 and PIs will be equal to 1, 2, 3, 1, 2, 3, 4, 5, and SPIs will be equal to 2 and RPIs will be equal to 0. Is this clear? Yes. So this is how we are going to decide our EPIs, RPIs, SPIs are okay. And any K-map which is containing of SPI, there we will have two solutions that we should remember. Okay, any K-map which is going to have a SPI term, there we are going to have two number of solutions that we should be careful there. Okay. Yes, and if we are having an RPA term, then that particular term will not be appeared in the solution. Okay, and whereas if we are having an EPA term, that will be definitely observed in the solution. Okay, so yes, so that's about this EPA, RPA, SPA. So let me provide you some practice problem so that you can practice on this. 1 minute. Yes. So I will give one practice problem. Just try to find out how many PIs, how many EPAs, and how many RPAs and how many SPAs are there. And the solution we will discuss in the next session. Okay. So let's say we have a four variable function like this. So we have a four variable function like this. Two, three. Total 16 number of cells we will have. So we have min terms like this: 1, 1, 1, 1, 1, 1, 1, and here also 1. Okay. So for this, we need to find how many EPS are there, how many RPS are there, and how many SPS are there. Okay. And one more example. So for this also, we need to find how many EPS, how many RPS, and how many SPS are there. And one more last one. So these are the three conditions we can check for how many PAs are there, how many EPAs are there, how many SPAs are there. Okay. Yes. Okay. Is it clear?